Hello everyone, welcome back to our channel. In today's session, we'll guide you through the process of configuring Prometheus and Grafana for monitoring AWS EKS, which is Elastic Kubernetes Service. So by integrating these tools, you can effectively track metrics, set alerts, and visualize your data. And this will ensure optimal performance for your EKS cluster. So these are the table of contents which we are going to learn today. We'll start with understanding what is EKS, then what is Grafana and what is Prometheus. Then we will learn why we are using helm to install Prometheus and Grafana. Then you should know some prerequisites before you start with your practical. So you should have an AWS account with IAM user and your AWS credential to set up locally by using command AWS configure. So you should, after configure, you should enter your access key and secret key created. Then you need to have an Ubuntu server instance with the sudo access. Then we will learn about the steps for monitoring AWS EKS using Prometheus and Grafana, which include the setup of kubectl, then the installation and setup of eksctl. Then we will install helm chart on our Ubuntu server, which will help to install Prometheus and Grafana. Then we will create an Amazon EKS cluster using eksctl tool. Then we will add the helm stable charts for our local client. Then we will add the Prometheus helm repository. Then we will create the Prometheus namespace where we are going to install the Prometheus and Grafana. And then we will expose the Prometheus and Grafana by using load balance. And in the end, then we will delete the cluster by using EKS delete cluster command. Then we will conclude for today. So let's start. So what is Amazon EKS? So Amazon EKS is a managed Kubernetes service provided by Amazon Web Services. So it simplifies the process of deploying, managing, and scaling containerized applications using Kubernetes on AWS infrastructure. So for example, imagine a software development team which wants to deploy a microservices-based application using container. So instead of managing a Kubernetes cluster themselves, they can use Amazon EKS. So which will they define application architecture, specify resource requirements, and deploy it to the EKS cluster. As Amazon EKS take care of provisioning and managing Kubernetes control plane, worker nodes, networking, and other infrastructure components. So this will allow the team to focus on deploying the application while benefiting from the scalability, reliability, and flexibility of Kubernetes on AWS. Now let's learn about Grafana. So what is Grafana? So Grafana is an open source tool for performing data analytics, retrieving metrics that make sense of large amounts of data, and monitoring our apps using nice configurable dashboard. So Grafana integrates with a wide range of data sources including Graphite, Prometheus, InfluxDB, Elasticsearch, MySQL, PostgreSQL, and others. So when connected to supported data sources, it will provide web-based charts, graphs, and alerts. Now, what is Prometheus? So Prometheus is an open source monitoring and alerting toolkit designed for reliability and scalability in modern and dynamic environments. So it was developed by the Cloud Native Computing Foundation, which Prometheus excels at collecting and storing time series data, allowing users to gain valuable insight into the performance and health of their application and infrastructure. So with its powerful query language and support for multidimensional data, Prometheus has become a popular choice for monitoring system with cloud native ecosystem. So you can refer the article which is available on Cost Techniques, which will have the Monitoring AWS EKS architecture. So you can visit the first technique site where you can find this article. And if you click on this, you can find the architecture in which it will pull metrics from the Prometheus server, and we have used Grafana for visualization of the Kubernetes cluster. So it will have the default dashboard which include the Kubernetes cluster, and we will monitor it. Now next, so why we use Helm? So as Helm serves as package manager for Kubernetes environments. So with Helm, deploying complex application or managing multiple resources becomes simplified and streamlined. So as Helm provides advantage like package management, which Helm offers a structured way to manage and organize Kubernetes manifest, making it easier to deploy and manage application and services within your cluster. And it also provides simplified installation, as Helm drastically simplifies the installation process by enabling you to install all the required components with a single command. Then it provides efficiency. So by utilizing Helm, you can ensure that your Kubernetes deployments are efficient and consistent. And in essence, Helm empowers Kubernetes users to streamline the deployment workflows, enhance efficiency, and maintain consistency across the infrastructure. Now, as we have learned about the prerequisites, here you can find that I have created an EC2 instance where we are going to install kubectl, eksctl utility tools, and then we are going to create a cluster with the help of eksctl tool. So now we will move on to forward for and see the steps for monitoring the AWS EKS. So first step is to install and set up the kubectl on our Ubuntu server. So as I have connected my instance using Mobaxterm tool, so you can also use get and Mobaxterm tool to connect to the instance. So here you can find that I have connected using Mobaxterm. So first step is to update the system. So simply type sudo apt update. Now after we have complete with the updation of the system, now we are going to install and set up kubectl on our Ubuntu server. So installing and setting up kubectl configures the command line interface essential for managing Kubernetes cluster. So you can find here the command which will help us to install the kubectl on our Ubuntu server. So simply copy this command and paste here. So as you can see, sudo equals silent location, which we use curl to download the kubectl binary for Linux from an Amazon EKS URL. Here is the URL. And then we have saved that downloaded binary to the user local bin, which will make then kubectl permission will grant the executable permission to the kubectl binary. And then we have checked the version of the kubectl, so which is 1.22.6. So with the help of chmod, it will grant the executable permission to the kubectl binary. Now we have installed kubectl successfully. Now our next step is to install and set up eksctl on our Ubuntu server. So installing and setting up eksctl simplifies the process of creating and managing Amazon EKS cluster with its command line utility. So simply copy this command and paste here and press enter. Then we will move the extracted binary to the user local pin. Now after installation, we will check the eksctl version. So as you can see, the version is 0.173.0. So basically the curl silent location, as we have downloaded the kubectl, it downloads the eksctl binary tarball, extract it and store it in the temp directory. So it is stored in the temp directory, here you can find. And then we have moved the extracted eksctl binary from temp to the user local bin directory. Then we have simply, to get the version of eksctl, we have typed the command eksctl version. So in which it will give the version, and it is 0.173.0. So we have installed eksctl successfully. Now let's move forward. Now our next step is to install the help chart on our Ubuntu server. So installing help charts involves deploying pre-configured packages onto Kubernetes cluster. So same as above, you just need to copy this command and paste it. So same as above, it uses curl to download the helm installation script, which is from the specified URL. And then you can find that fssl flag make the curl command fail silently, which follow redirects and download the file with the same name, which is gethelm.sh. And then it changes the permission to the downloaded gethelm.sh script to make it executable. So here I have mentioned the permission. And it uses chmod to set the permission of gethelm.sh to allow execution for the owner, which is 7 is equal to read, write, and execute. Then it executes the get helm script, which installs helm version 3.8.2. And there is another way to install the helm version 3.8.2 is by using the shortened URL. Now we are done with the installation of helm. So just type, to check the version again, just type helm version. And here you can find we are currently using 3.8.2 helm version. So please use these versions of helm 3.8.2, as if you are not using this version and if you are using the latest version, then it will give the error of the version error. Now here we are done with the installation of kubectl, eksctl, and helm. So let's move forward, and now we are going to create an Amazon EKS cluster using the eksctl tool. So just copy this command and paste it. So creating an Amazon EKS cluster using eksctl streamlines the process of setting up and managing Kubernetes cluster on AWS. So it will provide a simplified command line interface for creating EKS cluster with predefined configuration, ensuring efficient cluster deploy. So as here you can find that to create EKS cluster, I have used this command. So where eksctl create cluster which will initialize the creation of EKS cluster. Then I have specified the name of the cluster which is EKS cluster. And then so this is the flag which I have mentioned to give the name of the cluster. Then I have specified the region so where I have to create a EKS cluster, so which is AP South 1. And then I have specified the version, and if you not specified the version here, it will create EKS cluster in the default version. Then I have created the node group which I have named as my nodes, and then the node type which I have specified as the instance type for node is t3.medium, and then the flag managed which will configure the node group as managed by EKS. Then the nodes are set to 2, which will set the initial number of the nodes 2, and the nodes minimum, which will specify the minimum number of nodes which is set to 2, and the maximum number of nodes is set to 3. Now, now just press enter to create cluster. So as you can see, it is giving error. So the error was as I have not configured the AWS. So after configuration of AWS by specifying access key and secret key, now just type this command and press enter. So as you can see, it has started the process of creation of EKS cluster on our AWS account. So as you can see, it will take around 15 minutes to create cluster on our AWS account. So let's wait for some time. So here you can see that EKS cluster has been created successfully. So we will verify this on our AWS account. So here, if you refresh this page, so just type here AWS EKS and just click on Elastic Kubernetes Service, and if you refresh this, here you can find our EKS cluster has been created successfully with the status active, and the version we are currently using is 1.29. And if you click on the EKS cluster, it will give the required details. Here you can find the networking, the VPC, and the subnets created. And in compute, here you can find the nodes information where we have created instance of t3.medium. And if you click on the instances, it will give here you can find the instances has been created successfully. Now, our next step is to Update the kube config by entering AWS EKS update kube config. If you have version error, then just type this command, the cluster name, which is EKS cluster, and the region, which is AP South 1, and just click. So as you can see, we have updated the config file successfully. So just clear this. Now our next step is to connect the EKS cluster using the kubectl commands. So to view the list of the worker node as a part of EKS cluster, so just type the simple command kubectl get nodes. So it will give the information of the nodes created. Next, just type kubectl get ns, which will give the namespace. So here you can find there are four namespaces, which is of default cube node is cube public and cube system. Now let's move on to our next step, which is to add Helm stable charts in your local client machine. So we need to add the Helm stable charts for our local client and just copy the command to add the Helm stable chart. So just press enter. So as you can see, table has been added to our repository. To view the repository, so just type helm repo list. Here you can find that repository of stable has been created successfully. So as you can see, the command helm repo add is the part of the command where we add a new helm repository to our local helm configuration. And this table is the name of the given helm repository being added. And in this case, the repository is named stable, but you can refer your name according to your requirement. And this is the URL of the Helm repository. So it will specify where the Helm should look for charts, packages of pre-configured Kubernetes resources when you use the repository to install application. So basically when you run this command, it will create the stable repository with the specified URL to our local Helm configuration. And this will enable us to search for, install and manage Helm charts from this stable repository using the helm command. So we have successfully installed the Helm stable chart repository. Now let's move forward and add Prometheus Helm repository. So simply copy this command to add the Prometheus repository. Just clear this. Press enter and here you can find the Prometheus community, which is the name of the repository has been added successfully. To view the repository, just type helm list and repo list, and you can find the Prometheus repository have been created successfully. So as you can find the command helm repo add Prometheus community and the URL is used to add the helm repository named as Prometheus community, which is specified with a specified URL. So with the help of help repo add as we have seen previously, this part of command is used to add a new Helm repository to our local Helm configuration, and the name of the repository is Prometheus community with the URL, and the help charts will specify the URL in the Prometheus community, which contains the charts related to Prometheus and all related to monitoring tools. So when you run this command, it will create a repository with the specified URL to our local Helm configuration, and this will allow us to install and manage Helm charts related to Prometheus and monitoring tools from the Prometheus community repository using Helm command. So we have added stable and Prometheus repo successfully. Now our next step is to create the Prometheus namespace. So this step we have done successfully. Now our next step is to create Prometheus namespace. So simply type the command kubectl create namespace, and the name of the namespace which we are going to give as Prometheus, and press enter. To check that the namespace has been added or not, just type kubectl get ns, which will give the namespace list. And here you can find that Prometheus have been added successfully. And it will also give the age where we have created it in 7 seconds. So the purpose of creating a namespace is in Kubernetes is to divide the cluster resources into virtual groups. So as they are often used to create the isolated environments for different project teams or application within the same Kubernetes cluster. So, so by creating this namespace called as Prometheus, will segregate the resources related to Prometheus monitoring within this namespace. So this segregation will help in organizing and managing resources more effectively, especially in multi-tenant or complex cluster environments. Now our next step is to install Prometheus using helm. So after we have added the namespace, now our next step is to install Prometheus using helm. So just copy this command and paste it. So as you can find, the command which will install the stable Prometheus. So the helm install is the helm command where you use to install a helm chart package of pre-configured Kubernetes resources into Kubernetes cluster, and the stable which will refer the helm repository for which the chart will be installed. And in this case, the chart is being installed in the stable repository. Then you can find the Prometheus community kube Prometheus stack. So this will refer to the Helm repository created namespace as Prometheus community, and it will specify the namespace from which the chart should be fetched. So in this case, it's Prometheus community repository. So this chart will include a full-fledged Prometheus monitoring stack, including Prometheus, Grafana, Alert Manager, and related components. And the hyphen n Prometheus will specify the namespace in which chart should be installed. So now the purpose of this command is to install the Prometheus monitoring stack, including Prometheus server, Grafana for visualization, and Alert Manager for alerting and other components into Kubernetes cluster. So just press enter. So we have installed Prometheus by using helm successfully. So now to verify if Prometheus has been successfully installed using helm on a EC2 instance, so just enter the command kubectl get pods -n and the name, which is Prometheus. So here you can find the namespace detail, the status has been deployed, and etc. So here you can find all the files, the stable, cube, Prometheus, node exporter, and etc. So the inclusion of the Grafana alongside Prometheus in this stable version confirms the successful installation of the Prometheus. And since the Grafana is bundled with the Prometheus, so there is no need to install Grafana as a separate installation. So there is no need for installation of Grafana. Now our next step is to expose the Prometheus and Grafana to the external world. So, so let's expose the Prometheus and Grafana. So basically there are two ways to expose, through the node port and through the load balancer. So let's go with the load balancer. So to attach the load balancer, we need to change the cluster IP to the load balancer. So simply type the command to get the SVC file. So just copy this command to edit the SVC where we have to edit the cluster IP to load balancer. So here you can find the file, and if you go down and find your type, so just replace the cluster IP to load balancer. So just type insert, then clear this and type here load balance. And after you have successfully entered your load balancer, just enter escape :WQ, which will save the file. And here you can find that it has been edited successfully. Now after this, now just type this command to get the URL of the Prometheus server. So here you can find the URL as we have viewed load balancer. So just copy this. So just copy this URL and paste on your browser. So as you can see, site can't be reached. So just put your colon. So you need to change the security settings of your instance. So let's change the settings. So click on your EKS cluster, then click on the security and click on the first security group. So click on your edit and delete the existing rules and add a rule and select your all traffic and anywhere. So now refresh this page. So before that, let's edit the SVC file of Grafana. So which will give the URL for the Grafana. So just enter your cluster IP, click on insert, then just type your load balancer as we have previously done for Prometheus and save this by entering escape:\wq and get the URL for the Prometheus as well as for Grafana server. So just copy the URL. Now we need to change the security group settings. So as you can see, I have changed the settings of the security group called as Kubernetes Elastic Load Balancer and added vault traffic to custom anywhere. So because of this, I can access the login page of Grafana. So here you can find, if you refresh this, this is the Grafana login page. So now our next step is to create the username and password to log in Grafana. So simply copy this code which will give you the password to log in the Grafana page. So as you can see, prom operator is your password. So simply and enter your admin and password. Here you can find the password is prom operator. So basically this kubectl get secret will give the so basically this overall command kubectl get secret will retrieve the base 64 encoded admin password value from the stable Grafana secret in the Prometheus namespace. So using kubectl get secret. So it then decodes the base 64 encoded password using the base 64 decode. And finally, it prints the decoded password using echo. So in this summary, this command will retrieve the admin password stored in the Kubernetes secret name stable Grafana in the Prometheus namespace, and it is decoded and decodes it from base 64 and print it, and it has printed the password successfully. Now just click on login, select never. So if you now just click on dashboards and here you can find and here you can monitor the Kubernetes cluster. And here I have modified and edited the inbound rules and removed the default security group and just allow all the traffic. And here you can find, if you copy the URL for Prometheus and just type current 1990, which is the port for Prometheus to run, and here you can find the Prometheus server UI user interface. And if you click on status here, you can find that all the script post details here are present. So with the help of Prometheus, it's scraping the metrics from the Kubernetes cluster, and with the help of Grafana, we are visualizing it So in the Grafana dashboard, we can view the entire data of the cluster. So where we can able to see the entire data of the EKS cluster such as CPU, RAM, ports in specific namespace, pod of history, resource by container, CPU use container limit, network bandwidth and packet rate. So for example, if you click on here, you can find the CPU utilization, memory utilization is how much. With the help of Grafana, you can visualize the data. So we have successfully performed the practical for monitoring EKS by using Prometheus and Grafana tool. And now the last step is to clean up and delete the cluster. So to delete the cluster, simply type here eksctl delete cluster hyphen name of the cluster, which is EKS cluster. So it will take around 8 to 10 minutes to delete the cluster. So as you can see, it has been initialized the process to delete the cluster. So as we have performed our practical successfully, we'll conclude for today. So in conclusion, setting up Prometheus and Grafana dashboard for monitoring AWS EKS offers a robust solution for observing and managing our Kubernetes cluster. So with Prometheus collecting metrics and Grafana providing visualization capability, users gain insight into cluster health, resource utilization, and performance metrics. So thank you for watching the video. And here you can find that it will be deleted and it only require 8 to 10 minutes to delete. So thank you for watching the video and please do like, share and subscribe the channel and see you in the next video. Thank you.